Hello, in this example we need to find the exact value of each of the remaining trigonometric functions of theta, given that sine of theta is negative 12 out of 13 and tangent of theta is greater than 0. So here we have x and y axes. All students take calculus. What this stands for is that all are positive in the first quadrant, sine and its reciprocal in the second quadrant, tangent and its reciprocal in the third quadrant, and cosine and its reciprocal in the fourth quadrant. In the problem, we are given that sine of theta is negative 12 out of 13, which means that sine is negative. This means that angle theta cannot be in the first quadrant or the second one because sine is positive in both of these. We are given that tangent of theta is greater than 0. This means that tangent is positive. That means that the angle theta cannot be in the second quadrant because only sine is positive there, and angle theta cannot be in the fourth quadrant because only cosine is positive there. This means that theta, the angle, is in the third quadrant. So the reference angle is about here. Once you have this figured out, you can absolutely use a reference triangle or the definitions for trigonometric functions of any angle. I am going to use definitions in this video, but you can absolutely drop a perpendicular to the x-axis, label angle theta with the x-axis as well, and mark the opposite side 12 because sine is opposite out of hypotenuse 13. Or you can use the fact that sine of theta is equal to y out of r. R is always positive, this 13 hypotenuse, whatever you want to call it. So r will be equal to positive 13, which will make y being equal to negative 12. If you're using reference triangle, just realize that below the x-axis, y values are going towards negative infinity. So this y value, the height is equal to negative 12. Now the only thing that you need to calculate from here is the adjacent side to the angle theta, and it's the x value. We know it's going to be negative because x goes towards negative infinity in this quadrant. You can absolutely use Pythagorean theorem to find x. In this example, however, I'm going to use r squared equals to x squared plus y squared because it doesn't require for me to replace variables. So we know that r is equal to 13, so 13 squared equals to, we don't know what x is, so x squared plus y is equal to negative 12, so plus negative 12 to the second power. 13 squared is 169 equals to x squared. Negative times negative, we get a positive. 12 squared is 144. In order to solve for x squared, we need to do the inverse of adding 144, so we will subtract 144. Whatever we do to one side of the equation, we have to do the same thing to the other side, so minus 144. 169 minus 144 is equal to 25, equals to x to the second, and this adds up to 0. Now we need to do the inverse of squaring x, which is a square root. Whatever we do to one side of the equation, we have to do the same thing to the other side. So square root of 25. Square and a square root will cancel, and we get x is equal to negative 5. And this will be our solution for x, because remember, it's either positive or negative 5 to the second power will give you positive 25 as a solution. So now we have that x is equal to negative 5, and we can set up our trigonometric functions of theta. So we are given sine of theta is negative 12 out of 13. From this we can find cosecant of theta, which is just a reciprocal of sine, and reciprocal of negative 12 out of 13 will be negative 13 out of 12. We know that cosine of theta is x out of r. So cosine of theta is equal to x is -5 out of r is 13. So cosine of theta is -5 out of 13. Once we have cosine, we have secant of theta, which is a reciprocal of that. So reciprocal of -5 out of 13 is -13 out of 5. So secant of theta is -13 out of 5. And tangent of theta is equal to y out of x. So we get tangent of theta is equal to y is -12 out of x is -5. So tangent of theta is equal to negative divided by negative positive 12 out of 5. Once you have tangent, we can find cotangent of theta, which is just a reciprocal of 12 out of 5, and it's going to be 5 out of 12. Cotangent of theta will be 5 out of 12, and this will be our solution. That's all.